The vector equation of two lines L and M are given. Part A, we need to show that the two lines are perpendicular. Now for line M here, this part gives the direction vector for line L. Let's say this is vector U. And for line M, negative I plus 2j plus 2k is the direction vector of line M. If two lines are perpendicular, then the direction vector must be perpendicular as well. Two vectors are perpendicular if their dot product is 0. In order to show that line L and line M are perpendicular, we need to show that the dot product of their direction vector must be 0. So U here is given by 4, -1, and 3, and vector V is given by -1, 2, and 2. And this will give us -4 minus 2 plus 6, which is 0. Since the dot product of the two direction vectors is 0, this means that vector U must be perpendicular to vector V, indicating that L must be perpendicular to M. Part B, we need to show that line L and line M intersect. So if line L and line M intersect, that means there must be a point of intersection. So first, line L here can be written in the form of 3, 2, 5 in component form, plus this is 4s minus s and 3s. Line M can be written in component form as 1, -1, -2 plus -t, 2t, and 2t. If they intersect, then we can equate both of them. There must be a common position vector. So equating these two, we have 3, 2, 5 plus 4s, -s, 3s. This equals 1, -1, -2 plus -t, 2t, and 2t. Equating components of vector I, we have 3 plus 4s equals 1 minus t. Rearranging, move this over and that's over. We have 4s plus t equals -2. Let's say this is equation number 1. Equating components of vector j, 2 minus s equals -1 plus 2t. So upon rearrangement, we have s plus 2t equals 3. That gives us equation number 2. And equating components of vector k, 5 plus 3s equals -2 plus 2t. So that 3s minus 2t is -7. That will give us equation number 3. There are 3 equations with 2 unknowns. If the line intersect, we will be able to find unique values of s and t that satisfy all 3 equations. So what we could do is we solve equation number 2 and 3 to find the values of s and t and check that this is consistent for equation number 1. So in that case, from equation number 1 and 2, we can use the technique of elimination. Let's say we add equation 2 to equation 3. We have 4s. T is eliminated. This will give us -4. Dividing throughout by 4, and we have s equals -1. Okay, now we need to find the value of t using equation 2 or 3. So we can sub s equals -1 into equation number 2. Then we have -1 plus 2t equals 3. And that will give us 2t equals 4, so that t is 2. We have values of s and t. If this value gives a consistent solution to equation number 1, then we know that the two lines intersect. Otherwise, they do not intersect. So to check that these are consistent values, we can sub s equals -1 and t equals 2 into equation number 1. So we look at the left side of equation number 1. We have 4s plus t. So that will give us 4 times -1 plus 2. And we have -4 plus 2, which is -2. And this is the same as the right side. So we know that the values of s and t are consistent. So in that case, you see that s and t are consistent. And from here, we say that line L and line M intersect. To find the position vector of the point of intersection, what we need is to replace s or t into either equation of line L or equation of line M. We can always substitute t equals 2 into the equation of line M. So R here is 1, -1, -2, plus t is 2, so you have -2, 2 times 2 is 4 and 4. And that gives us a value of -1, 3, and 2. Then in that case, we say that the position vector of the point of intersection, this is -I plus 3j plus 2k. Part C, we need to show that the length of the perpendicular from the origin to the line M is 1/3 square root 5. So the length of the perpendicular from the origin. Now part C here. You have the Z, Y, and the X axis. So let's say you have line M here, and line M is given by, so we have line M here. Line M is given by R equals 1 minus 1 minus 2 plus T minus 1, 2, and 2. That is the equation of line M. Now we need to show that the length of the perpendicular from the origin. This is the origin. So from the origin to the line, making a 90-degree angle, that will give you the perpendicular to line M from the origin. So this perpendicular, this end here, the foot of the perpendicular is on the line M. Let's say the foot of the perpendicular is given by point A. Then point A is just a general point on line M. It will have coordinates 1 minus T, minus 1 plus 2T, and minus 2 plus 2T. And we can form vector O for this case. So we can form vector OA here. Vector OA is given by 1 minus t minus 1 plus 2t and minus 2 plus 2t here. So this gives us vector OA. And we know that vector OA is perpendicular to the line. If vector OA is perpendicular to the line, then the dot product of vector OA, which is 1 minus t, minus 1 plus 2t, and minus 2 plus 2t, we dot this with the direction vector of the line, minus 1, 2, and 2. The dot product must be 0, since vector OA is perpendicular to the line. Evaluating the dot product, we have minus 1 plus t, minus 2 plus 4t, minus 4 plus 4t equals 0. That will give us 9t minus 7 equals 0. That means t must be 7 over 9. For vector OA to be perpendicular to the line, so t must have a value of 7 over 9. Then we say that vector OA is given by 1 minus 7 over 9, negative 1 plus 2 times t, that is 14 over 9. Then we have negative 2 plus 14 over 9. That will give us 9 minus 7. This is 2 over 9. And we have 5 over 9 minus 4 over 9. That is vector OA. The length of vector OA, or the magnitude of vector OA, is the length of the perpendicular from the origin to line M. Basically, for this part, you need to find the magnitude of vector OA. That is the distance. Let's say this perpendicular distance. We need to find this perpendicular distance, and that perpendicular distance is the magnitude of vector OA. So that will give us the positive square root of the sum of squares of the components. That would be 5 over 9 and negative 4 over 9. So from here, that will give a square root of 4 over 81, 25 over 81, and 16 over 81, which is the square root of 45 over 81. Square root of 45 is square root of 9 and square root of 5. Then we have square root of 81. That will give us 3 square root 5 over 9, which is 1 over 3 square root of 5.